Hello chemistry students, this is the video key for the Unit 4 Ionic and Metallic Bonding Learning Readiness Quiz, which covers objectives 2 and 3. We went over some of these problems in class, but I just wanted to make sure that you knew how to solve them so that you could get ready for the re-quiz. Okay, so let's take a look first at number 1. Here we have to draw the electron dot structures for an oxygen atom. Recall that electron dot structures, also known as Lewis structures, involve writing out the abbreviation for the element and then drawing the number of valence electrons that the element contains. So oxygen is in column 6 on your periodic table. And if you don't have your chem helper out, you should probably pause this video right now and go ahead and get that out so you have it next to you. So to draw the electron dot structure for the oxygen atom, we're going to draw our abbreviation for oxygen, which is O, and oxygen is in column 6. It has 6 valence electrons. So I'm going to draw 6 dots for those valence electrons, like so. Notice that you should have 2 electrons that don't have a partner. So that's the oxygen atom. The oxygen ion is going to form when the oxygen atom that you see over there, so I'm just going to copy what I have for oxygen atom, gains 2 electrons in order to have a full valence shell. And remember that a full valence shell means that the atom has 8 electrons. And since now oxygen gained 2 electrons, it gained 2 negative particles, that means that the atom, which was neutral, now has a charge. And the charge is -2 or 2 minus. So in order to get full credit for that one, you had to have the charge on there. So remember that ions have charge, atoms are neutral. Last, we have the helium atom. And even though helium is in group 8, helium is one of the exceptions to the rule, and it only has 2 valence electrons. And so that is helium. Number 2, we have to draw the electron dot structure for a compound that forms between calcium and fluorine. Well, the first thing to do is to draw the electron dot diagram for each element. So calcium is in column 2, so it has 2 valence electrons, and fluorine is in column 7, so it has 7 valence electrons. So what's going to happen here is that fluorine, since it's more electronegative than calcium, is going to steal an electron from calcium. Now this fluorine is going to have a -1 charge because it gained an electron. Our calcium lost 1 electron, but we're not done, because calcium, remember, is a metal, and metals have to lose all of their valence electrons in order to achieve a full shell. So our calcium needs another place to have its last electron go to. So we need to draw another fluorine, because we're making a compound that's only composed of calcium and fluorine. And so my second calcium electron is going to come here by this other fluorine atom. And when fluorine gains that electron, it has a negative charge. Now, because our calcium lost 2 electrons, because it lost negative charge, it now has a positive charge, and its charge is now +2. But that's not our answer. That was just the work. That's like doing the work in a math problem. And now what we have to do is kind of combine it. We want to try and represent the ionic crystal that is created when calcium ions are attracted to fluoride ions. So in order to do this, we're going to put the least abundant atom, or the element that we have the least amount of, in the middle, and that's calcium. And calcium, as I said, has a +2 charge. I'm not going to put any dots around calcium because calcium lost all of its electrons, so there aren't any dots to draw. Now let's draw fluorides. I'm going to put my fluorides on either side of calcium. Why? Because if I put them together, then the particles are going to repel, because like charges repel. So my fluorine has 8 electrons and has a -1 charge, and this fluorine also has 8 with a -1 charge. And that's my final answer. And by the way, if you add a -1 plus a +2 plus a -1, the total charge on my compound is 0. And that's exactly what we want. Okay, moving on to number 3. We're going to be writing the formulas for the following ionic compounds. So if you take a look at your chem helper, find magnesium. Magnesium is in the second column. And if you look at the very top of the column, it tells you the charge that it creates when it loses electrons. It's going to create a charge of +2. And phosphide is in the same group as nitrogen, which is group number 5, and if you look above that, it has a charge of -3. So we have magnesium with a charge of +2, we have phosphide with a charge of -3, and when we switch our numbers, we're going to write the 3 down here by magnesium, and we're going to write the 2 down here by phosphide, and we get Mg3P2. Next we have lithium sulfide. Lithium has a charge of +1 and sulfide has a charge of -2. And so we're going to bring the 1 down here by sulfur and put the 2 over here by lithium, and we get Li2S. Now you're probably wondering, well, where did the 1 go next to the S? You've got to remember that in chemistry we don't really write the 1s, so I'm not going to put it there. All right, so A and B both had anions that ended in IDE. So we were just looking at the periodic table of elements in order to find out what the charge is. When you have an anion that ends with the letters ATE, that means that it's a polyatomic ion, and you need to look at your list of polyatomic ions that's on the back of the chem helper. So aluminum, I'm going to change colors, has a charge of +3. You know that because it's on the front of the chem helper. And carbonate has a formula of CO3, and it has a -2 charge. So in order to write this compound's formula, we're going to put the 3 over here by carbonate, and the 2 is going to come down next to aluminum, so we get Al2. CO3, so whatever's inside of the parentheses remains in the parentheses, and then I'm going to put my 3 on the outside. And so that is the formula for aluminum carbonate. Now, this is something that you just have to memorize. Hydroxide, even though it has an IDE ending, that is a polyatomic ion, so you have to find that on the back of your chem helper because there is no element named hydroxide. So, you know, if you're looking for a hydroxide on the periodic table and you're like, I can't find it, flip over your chem helper and you'll find it in the list of polyatomic ions. So sodium has a charge of +1, and hydroxide has a charge of -1. So since +1 and -1 cancel each other out, we only need 1 sodium and 1 hydroxide, and my formula is NaOH. Okay, now we have to write the names for this, and in order to do that, all you do is name the metal and then name the anion. So when you name the metal, if you cover that up, if you've only got 1 capital letter left, then that means that it's an element and it's on the front of your periodic table. If, like down here by letter D, if you name the metal and you cross it out and you still have 2 or more capital letters, that means that you have a polyatomic ion. And that means that you have to flip your chem helper over so that you can figure out what the name of that polyatomic ion is. So here are your answers for this section. This one is called magnesium nitride, because remember, you have to change the ending of your anion to IDE if it's an element on the periodic table. The next one is beryllium oxide. And now C and D have polyatomic ions. Letter C is potassium phosphate. And letter D is strontium nitrate. And again, you just have to start becoming familiar with those polyatomic ions. You don't have to memorize them, but you need to know like when you need to flip over the chem helper so that you can find the name of it. All right, so those are the answers to the learning readiness quiz that you guys just took. I hope this is helpful, and hopefully you can do better on the re-quiz on Monday. Bye now.